Hello everyone. So today, uh, yes. So today this is the week 4 of the NPTEL Swayam course, which is unit operations of particulate matter. So unit operations of particulate matter, and this is the week 4, last week of the course. So like you started with the sedimentation, in that gas sedimentation and centrifugal sedimentation for the week 1, and in the week 2 you had we had discussion about the filtration and different types of pressure filtration, like constant pressure filtration and constant rate filtration, and the equipments in the filtration. And then we had discussion about in the third week of the lecture about the fluidization. No, about the fluidization, and like how different models of the fluidization is being done, like argon model, and different models which are being used. And now, in the last week, the two main topics that will be covered, and that has been already covered. And in this, we will be solving some of the numerical problems and questions related to whatever has been already taught to you. So those numericals will be helpful in solving the week 4 assignments, and whatever doubts you have regarding that. So let me see if somebody came in. Yes, Akansha same. So like unit operation of operation of particulate matter, in that the last week was about this fluidation, and in that afterwards you had this conveying system like transportation of solid. So these two were the major topic in last 5 lectures. So in that, like, we will be solving some of the numerical problems that will be helpful in terms of getting insight and solving the weekly assignment. So this if we go to the questions like week 4 assignment, and let me just see. Yes, yes. So this one is what assignment 4 is, this one. Yes. So let's open it, and one by one I will be putting these questions, and I will be giving 30 seconds or 1 minute depending on the question, and you have to look at it and solve it. So the first question is about flotation, and this question says, I will be putting it on the screen so that it is visible to you. Yes, this question is here. So this question says, which parameter is most important for higher recovery in the flotation process? So meanwhile, we will be looking at some discussion through the animations, like about the flotation and the conveyor belt and its type, and for which I have already referenced it. So whatever sources I am using. Which parameter is most important for higher recovery in flotation process? The option A is contact angle. Option B is surface roughness. Option C is both of the above, means both contact angle and the surface roughness. And the last option is none of the above. So You just try it and see, guess what, which option is correct. Meanwhile, I am putting some other questions. So this is the last week of the course. So after this, just the exams will be scheduled, and I hope this will help you. These are some problems which will be somewhere down the line from the slides, and similar questions will be asked in the final examination. So that is the next problem, and then yes. So so first question you are looking at right now. So the first question, which somebody again came, I think. Yes, Tejasvi has joined. Yes. So, which parameter is most important for higher recovery in the flotation process? Options are in front of you: contact angle, surface roughness, both of the above, none of the above. And if you remember, based on the discussion in the class, the contact angle played a vital role, and it has been proven, taking this like this is the solid surface, which is the particulate matter that need to be floated in that. If air is there, then this contact angle played vital role. Like if this liquid is there, so if the liquid comes in between the air bubble and the solid, and if it doesn't come, if air bubble he is having some contact with the solid. So in these two cases, you came to know that the contact angle is the major parameter that is controlling the strength by which air will be taking the solid particulate to the top of the vessel, which will be clear through this animation I will be showing you. Like suppose this is the vessel, and in this, initially all the particulates were there. You used all the coagulants and bubbled the air from the bottom, and subsequently what is happening, this there could be two things: if your particulate is hydrophilic or if it is a hydrophobic. And if that situation is there, there will be formation of what? There will be formation of a thin air layer if it is a hydrophobic, and if it is a hydrophilic, there will be water droplets coming to the contact at the particulate. So based on that, your particulate will be suspended or settled within the uh, flotation instrument. So based on that, at the end, what you will be having froth at the top, and this froth will be getting suspended because of the interface contact angle that air is making at the solid surface. This solid surface is the zoomed one. Actually, this is nothing but a particulate thing. And when you zoom it, it seems like it is a horizontal solid surface. So, in that sense, if you actually see the possible option, that is the one is the contact angle that plays the major role in flotation process. So let me take different color. Yes, so the contact angle is the correct answer. So this is clear from this video also. So let me see if it opens. Yes, no. So no. Yes, so let me just play this. Yes, so in this, Just look at the phenomena, what is happening. Air in concentrated and the pulp flow is there. So air is coming from the top. Sometimes air is blown from the bottom and sometimes it is blown from the top. And this is the way in which particulates are getting surrounded. And the example has been shown in terms of sulfide gang. And you see this sulfide is getting at the top and getting bursted. So in this way, froth are being collected from the concentrator at the top, and tails, whatever got settled, is at the bottom. So meanwhile, there will be various phenomena happening like bubble coalescence, and then there will be loss of the air at the top because anyway you are putting in some air, and this gang, some gains will be getting adhered to the air thing, but gradually before it reaches to the top, it settles. So if you see through this video, it is very clear that this the overall combination of all the factors, like whatever coagulants you have used, and again the coagulant, and at the same time the coagulant, and at the same time this some hustle. Am I audible? Let's see. Hmm. Yes. Tejaswini. Okay. Tejaswini is here. Am I audible, Tejaswini? And my screen is visible. So yes. Okay. Okay. Thank you. I thought some lag was there from this side. Yes. So this. Yes. So through this video, we got to know that this various factors that were responsible for the uh, for the suspension of the particulate that you want to separate. And if there is multiple particulates that are that has to be separated, then different kind of coagulants need to be used, and the decision and the choice of that coagulant depend definitely on the on the particulates that has to be separated. So for example, this flotation is the unit operation, no? And here the solid is separated from one another depending upon their difference in surface characteristics. So the surface characteristic is decided by the contact angle, and again the cohesive and the adhesive forces at the surface. So this flotation is a selective process for separating mineral from gang by using surfactant and wetting agents. So how these wetting agents and surfactants are playing its role? The selective separation of the mineral makes process complex or economically feasible. Okay. So this, if you see there, the basic structure has already explained how the contact angle plays a vital role in in deciding whether the particulates will be coming up with the froth, or whether there will be efficient separation of the particulate from the this from the slurry, or there is a need of some other uh, factors. So I will be putting up the discussion that has already been discussed in the class, and I will be explaining that again for the first question. So this entire discussion that we are doing is for the first question, and you see this the flotation depends on relative adsorption. So I will be putting the discussion that was there, the flotation mechanism, so that it actually helps you to be with me in the context of discussion. So there it has been told that the flotation depends on the relative adsorption or wetting of the solid by fluid, Obviously this is controlled by the surface surface energy or interfacial tension, which is gamma sigma. If the solid is easily and completely wettable by the water, like I told here, like if it is wettable by the water or if it is hydrophobic, so it will be wettable by the gas or air molecule. So based on that, there will be choices coming up into the picture, and those choices has to be made based on the kind of particulate matter you are dealing with. So you see even this one, and this, let me just take the content and then we will be discussing about this thing. So see, the flotation is depending upon how the what is happening at the surface, like relative adsorption or the wetting of the solid by the fluid. So if this air is between air and the solid, there is a thin film of liquid. This surrounding area is the liquid one. So this will be creating non-wetting condition for the air to solid. So in that sense, if you see the existence in the second case, in the first case, you see there is, if the solid is easily and completely wettable by the water, the liquid will exist as a skin between the solid and the air, and there is no point of contact of the three phase. Okay, but in this case the contact angle theta is then equal to the zero, and the solid will not float. Okay, so this condition is not desirable for, not not desirable. Let me just clean it again. And then, yes, this condition is not desirable for flotation. Okay, because air will be not able to take the solid to the froth, and the theta is then equal to the zero, and the here theta is zero, and the solid will not float. Solid will not float. Now if the surface of the solid is not completely wetting, okay, so this is not wetting, it means air will be going to the surface, means this is the condition of hydrophobic. Okay, and this is the condition of hydrophilic. Hydro hydro means water, philic means sluggy. Okay, so this move to an equilibrium position. So if the surface of the solid is not completely wetting, the liquid is forced to move to an equilibrium position when the surface tension force at the three phase interface is balanced. So what is the take home message here? If the magnitude of this work is large, means when air gets adhered to the solid, it takes the energy from the solid. So it means a lot of the work is to be expended to detach the bubble from the solid surface, or for decreasing the air solid interface. In other words, the air solid contact is quite strong, and therefore the floatability of the solid is large, and that is the desirable condition for the productivity of the plant wherever the flotation equipment is being employed. So based on that, we have calculated this. uh, this is actually getting calculated based on the contact angle measurement, which is this gamma GL between gas liquid, and this gamma SL. This is the theta, and this is gamma SG. And based on that, you have calculated this, uh, that what is the change in energy per unit surface area when these two, air and the solid, had contact between each other, and then you have converted that in terms of theta, and from this it can be observed that the large value of the contact angle theta means cos theta is small. So from the cos theta curve, you see this is the theta axis and this is the y axis, so y equals to cos theta. If you see, then the cos curve comes from the 1 at 0, and this goes like this. So from here you see the value of contact angle theta means if it is large, then cos theta is small. So if contact angle is increasing, cos theta is decreasing. And then till obviously 180 you are going, and which is indicates high flowability. So large contact angle value is good for high flowability. So large contact angle is desirable for large contact angle is desirable for high flotation stability. So this could be asked in the final exams in terms of energy also. So this has been asked in terms of contact angle, but it could also be asked in terms of energy. Like if the large value of the contact angle is there, then the value of the energy will be large. Okay, and that means that the flowability will be good. So that's all for the first problem that we were discussing. The second problem that I want you to think about is uh, which unit is not used in flotation cell. The options are scavenger, second option is rougher, third option is conditioner, and fourth option is palming. So this is a straightforward question. You just try, and you can also comment or write it down in the comments so that the lecture is a bit like maybe you have commented ball mill. Okay, so ball sir, is this the first? No, actually this is the last. This was 4 week course, this one, unit operations of particulate matter. So the 4 week course has been divided into like there were 20 lectures. So in each week 5 lectures are being posted from the side of Swayam. This course has been created from the IIT Roorkee head, and see for after each week lectures which is being delivered by the course instructor, there is one live class. Like I am taking this today, there has already been 3 recorded live class are there. So on the Swayam portal, Swayam app, so if you, I can show you, like if you want to see, suppose I am going here at Swayam NPTEL. So you just go at Swayam NPTEL online courses, and there you see here you have to log in. So I am having already logged in. So I will be opening through my mail ID. Okay, so this is the login that I am using. I just logged in here, and if you go in, yes, let me choose. Yes, I have chosen. So all the courses will be coming. So see, I have logged in through my mail ID, and now I will be going to my courses. So when I will go to my courses, then I will be showing you about this course. You see this unit operation of particulate matter. This course is the one that I am taking, and in this course, you see uh, all the 4 week lectures are there. So 16th Feb will be examination for the same, and you see these are week 0 was nothing, just assignment. Week 1 is the 5 lectures, week 2 is the 5 lecture. Week 1 was about sedimentation and the batch sedimentation and the centrifugal sedimentation, and week 2 is about filtration. So filtration, infiltration, batch filtration, continuous filtration, and everything. Week 3rd was about fluidization. So in that, liquid fluidization, gas fluidization. So for each week you are having assignments, and the solution is also being posted. And this is the week 4. So you see till week 3 you are given assignments and solution also, but week 4 is going on, so you are still not having solution. So these lectures are being made. So this is the problem solving session that I am taking. here you see this is the problem solving session, and in this already around 3 lectures are already there. So this is the fourth one that will be there. So one, two, three. Three is already there. This is the fourth one which is going on today. So you can access all the four videos which has already been done. Each are 2 hour classes, and I hope this helped. So this is the way you can find the lectures and use them as per your convenience. So this is you can find link from here, like I told, problem solving session recording. It is at the bottom in the Swayam NPTEL. I hope this helps. And I didn't receive any link for the lecture. This is my first class. Okay, so this is there. This has to be. This is being posted at the from the NPTEL side on their community. Maybe you have to regularly check their community, and again on the YouTube channel. I think they are actually posting. So I exactly don't know about that, but these are being posted. Okay, no problem. So what you do, all the lectures are there. Those lectures are already recorded, so you can go through that. There in each lectures there is around 20 questions that has been explained. So you may go to that. All the lectures are there. So this is the problem solving sessions, and 3 lectures are already submitted. So those lectures are there. When you go to this lecture, these are the YouTube link of the same lectures. If you go to this, yeah, this may be shown here. See, lesson one, week one, live session, week one, live session, week two, live session, week three. This is the live session, week three. So all are there. So today's will be live session, week four. So you can access them. I couldn't score well in the assignments. What? No problem. You try again, and anyway, final examination will be having more percentage, like around 75, I think. The assignments are having the end examination, which will be you will be giving after going to the examination center, that will be having more contribution to the final score. So no problem. Okay, so you try the another problem that I was discussing. Uh, the problem is yes, this one. So ball mill is the correct answer. So ball mill is not a cell, a flotation cell, not the part of the flotation cell. Okay, okay. So this now the third problem is resistance time is more in mechanical flotation cell, pneumatic flotation cell, both of the above, none of the above. And on the similar line, I am having some other questions also, so I will be putting them here. So you try this. Resistance time is more in which of the flotation cell? Meanwhile, I will be just solve them. Yes, these are the questions that I will be taking now. Till then, just focus on this. So as you remember, the mechanical flotation cell and the pneumatic flotation cells are there, and in the pneumatic flotation cells, you have been already told about that. You have to have more contact time. So Let me see if it is open. No. Yes, so I have to open it here. Yes. So you see, so this is the one question that I wanted to tell you, and so the question is these two questions are similar. So I will be putting that question two here beside that. So I will be putting two questions one after another so that yes, this okay. So which of the following is correct regarding pneumatic uh, let me increase the size. Yes. Which of the following is correct regarding pneumatic? Okay, why it came up? Yes. Regarding pneumatic cell, options are what happened? Yes. Okay. So options are vigorous agitation is used, mild agitation is used. They require 50% more contact time than the mechanical cells. Uh, Feed should be fully conditioned and floating agent before the charging to the cell, and compressed air is used for the agitation. So, as you remember, this was discussed in the section of the pneumatic uh, cell, and in that it has been told that the mild agitation is required and the 50% more time is required in that, and D and E option is also actually you require this compressed air, so compressed air has to be used, and this compressed air helps in actually taking surrounding the hydrophobic thing and subsequently leading to the flotation. So this compressed air is the correct option. Feed should be fully conditioned with the floating agents before. So promoter and the collector has to uh, be used. Those are nothing but the coagulants, and this option A is not correct. So vigorous agitation is required in the mechanical conveyor, not the pneumatic conveyors. So option B, C, D, E is correct answer. So mild agitation C, D, and these are correct answer. B, C, D is correct choice. And this resistance time is more in mechanical flotation cell, pneumatic flotation cell, both of the above, none of the above. So you try this also, which is correct. So here you understand that more in which resistance time is more in here. More contact time is required in the pneumatic thing. So these two questions is a bit clear to you, and they were around the this pneumatic conveying and pneumatic cell. And the next problem that I am putting it is about the conditioner that is used, and the question is this one. So we have already solved five questions. This is the sixth one. So this is this three plus one four, and this is the fifth one. I think. So this is conditioner is used inside the. It is used where? The option is mechanical flotation cell, pneumatic flotation cell, both of the above, none of the above. So if you remember this, also the pneumatic conveyor cell and the mechanical conveyor cells, if you remember the construction, then it will be easy for you to handle this question. So here, like this, where this conditioners are used. So you just think about this. So if you remember the pneumatic cell construction, there was nothing like this, this conditioner kind of thing. So basically, this slide will be helpful for this one. So let it be here. This question, these two questions were around this particular slide, and this conditioner is used inside what? So it is used inside mechanical conveyor. So this is not there in the pneumatic conveyor, so it is used inside mechanical conveyor. So maybe you are putting the answers there. See, yes, pneumatic is right. Yes. So there will be some numerical problem also. So like similar numerical problem as that has been explained in the class. One question was to calculate the throughput Q value. So exactly similar question will be asked, and the expressions will be provided in the examination. So those expressions are a bit tedious expressions. So you don't have to remember. You just have to understand the methodology, and you should understand the concept how to use that, and if the tables are being provided given, how to use them to reach to the final conclusion and what are they about. So the next problem is for transporting large quantity for long distance, which can be used. So large quantity for long distance, what can be used? So this is the very general question, and anyway this is related to these lectures, that's why I have put in for transporting large quantity for long distance, which can be used. The options are ships, rail, road, all of the above. Ships, rail, road, all of the above. What can be used? So this seems like some problem is there, like for transporting large quantity for long distance, which can be used. So in the last lecture, you have been told about the pneumatic conveying and the hydraulic conveying. So hydraulic convey and pneumatic conveying, and there, if you compare rail and road, ships are the good way. Waterways are the better way for the conveying. But if the fourth option was this hydraulic and the pneumatic, then if hydraulic or pneumatic conveying is given, then this one is the best option to choose. So option A is correct if this option is not given. So fifth is the one. Yes. Sir, how should I prepare for final exam as this is my first course on the NPTEL platform? So Tejasvi, the best way is like you go to each lectures, you will be definitely getting to know and understanding what you just go to the question answer sessions, and this problem solving sessions along with the assignments. So all the four assignment of the 4 week, and solutions are already there. So for you see for 3 weeks you are having solutions also. So solutions are already there, and this is the 4th week. So for only questions are there. Soon you will be given with the solution, but before you get the solution, you are having the problem solving sessions for each. So this problem solving session, along with this, you are having around 50 questions for each week. Like around 20 to 25 questions are in the problem solving session, and 10 to 15 questions are in the assignment. So based on that, just prepare those questions uh, you will be able to figure out like what kind of question could be asked. And the most important is in the fourth week, there has been 3 to 4 numerical problem that ma'am has explained. So it will be better if you actually solve them from your hand once. Similar question could be asked. Though if the expression is very difficult, those expressions will be provided in the examination or at the time of examination. But if those expressions are like it should be remembered, or it is if you could actually relate to suppose q is depending on viscosity in what way, so inversely proportional, directly proportional, somewhat that kind of question could be asked. But the questions will be conceptual. There could be most of the question will be multiple choice. Some could be like integer type also, so you have to just fill the answer, final answer. So questions will be somewhere around the lectures being given, and this assignments and the solver problem solving sessions will be anyway helpful. And after this you just look at the example problem that has been solved. So similar examples are also given in the assignments also, and in the live session of the question answer also. So just you solve these assignments and the and this problem solving session, you will be good to go for the examination. So I think exams will be on 16. So you have registered for the exam. So if yes, then you just okay, it is good now. At least you are giving. So you just prepare well. You go to all the lectures. So there will be some questions. There has been some questions I have given the solutions. Mostly all the questions that I have took, I have provided the solution. And just solve those questions that you think that could be asked in the exam. There are many questions that are actually involving the various graphical things, like you need to know graph, or you have to draw graph in excel or powerpoint excel, or you have to use green paper for the graph drawing. Those kind of question I don't think that will come, because in the examination you are not having that kind of tool to use that. So all the questions will be solvable, and small questions will be there, or conceptual questions will be there, that could be solved within the span of 3 hours. And that's it for this. So if you see, we have already solved the fifth question. Now we are moving towards the sixth question, and the sixth question is about this let me just put it here. Yes, the question is, which is not used to transport material to long distance: electrical trucks, dump body trucks, trolley, none of the above. Which of the following is not used? So for long distance. So this is again self-explanatory. This trolley you use through the hands. So this trolley could not be used for the long distance. Anyway, truck, electrical trucks, those are being used. So trolley is the correct answer. So these are small problems, but I will be taking some numerical problem also, or the multiple choice question type problem. So that will be anyway. Shortest route could be found in. So this question is similar to the one we have discussed. So I will be putting that also. This pneumatic transport problem, and this one is similar. So this, you see, shortest route could be found in what? In hydraulic. Hydraulic is the best one in terms of value for money also, and at the same time the kind of easiness that you are having. So another problem is like the question that I want to tell you is In the continuous discharge elevator, buckets are mounted. So in continuous discharge elevators, so this is continuous. Let me just correct this. Discharge elevator. This is a type of conveyor. In continuous discharge elevators, buckets are mounted at a specified spacing. So option A is at a specified spacing. Option B is those are close to each other. C is buckets are not used, and D is none of the above. Which of the following is correct answer? So, if you remember, in this continuous discharge elevators, buckets are there and they are close to each other. So, if you actually go to the slides of the course, then it will be more clear. So, if I can show you through the slides, continuous discharge elevator. So, if I can find that. Yes, so where is the continuous discharge elevator? So I will be taking that particular uh, part. Yes, I got it. So these are nothing but the bucket conveyor, and yes, this one. So if you remember, yes, this one. So the continuous discharge elevator is what? In a continuous discharge elevator, buckets are mounted without any gap, so they are close to each other. So option B is the correct one, and this is mainly used for lime, cement, and dry chemicals. So some questions could also be asked like match the column kind of thing, like which will be matched to what. So this continuous discharge elevator is matched to lime, cement, and the dry chemical. So that could also be asked in the exam. And now angle of repose increases capacity of apron conveyor. So this question will be helpful if you actually think it in two ways. First is the numerical could also be linked to this one, like in the angle of repose and those things are there. So angle of repose increases capacity of apron conveyor. So in the topic of the apron conveyor, if you remember, you have been told about the capacity. So this increases, it decreases, any of the above, and angle of repose is not considered. So apron, if you remember the apron conveyor bucket, so there this was well explained that how the angle of repose is leading to the capacity and how it depends on that. So that will be the we will be discussing. Just to be, where is that? So there has been one equation, and that actually tells you, right? Uh, this cos theta, yes, this is the one that I was talking about, the front conveyor, and this part was from this particular discussion. So let me just take it here. Anyway, I will be discussing completely the apron conveyor. So this is the one. You see, this is the angle of repose, and this is coming up into the throughput capacity. So the capacity of the conveyor. So this throughput capacity is leading to the efficiency of the conveyor, and at the same time the so belt conveyors are there. Then in that you had apron conveyors, and these apron conveyors are related to. So let me just take all the discussion that you had so that it will be easy for me to tell you things. So, and the question is around this particular these three slides only. That was well explained in the class, but the thing is very less factual questions will be there, but yes, this is in this course at least you remember some of the factual things like sand or those things which conveying facility will be used more. So this is it. So like apron conveyor are similar to the belt conveyor. So it is like on the airports we see when we go, those are belt conveyors. So this is like that only, except the solids are carried in moving through the called apron by virtue of its shape that is formed in articulated section of the wood or metal. So instead of continuous flexible belt. So if you see this video that I wanted to show, if you see this one,
Conveyor belts are an essential tool in the material handling sector. They are strips of continuous movement that are used to transport different
this is the
materials
belt
from one
conveyor,
place to another. It is mainly
and
used to transport large quantities of material in a short time. Conveyor belts are also called belts conveyors.
so see how this is
In
being
this
used in
video, we'll
transportation
discuss
of the
10 different types of
packaged
conveyor
food
belts.
items. So this is used in
Let's
the
get
food
started.
industry also.
Number 1. Cleated belt conveyor.
So these are
The
some
vertical
modern
cleats are distributed along the width of the
built
belt in the cleated
conveyors.
belt
So
conveyor.
this was not there in the lecture,
The
but yes,
function of
these are the
cleats is to
modern
support the material and
conveyors
realize
that are
large
being
angle
used
transportation.
along with the older one.
Number 2. Inclined belt
So
conveyor.
inclined belt conveyor we have
When
already
materials need
discussed,
to
like
be raised or
the angle
lowered,
should be
it is
20
often
degrees
necessary
or
to use
so.
inclined belt conveyors, but there is a certain limit to the tilt.
Okay.
Generally, the tilt-up angle
So
is
these
not more
are
than
our
18
conveyors.
degrees.
So around
Number
20
3.
degrees
Flat
is the
belt
one.
conveyor.
So this
A
is the
flat
belt
belt conveyor
conveyor.
has the general structure and characteristics of the belt conveyor, which is suitable for the transportation of irregular shape and lightweight objects, such as postal parcels, clothes, paper products, plastic products, etc. Number 4.
Is the trough
Trough
belt
belt conveyor.
conveyors. So you see,
The trough belt conveyor has a large loading and conveying capacity. The
so
conveyor belt of the trough belt conveyor adopts a multi-layer rubber belt
so
with a
this
belt
is
width of 500
what
mm,
are more
650
capacity.
mm, 800 mm,
So these are some extra.
1000 mm,
Whatever is extra, it will be
1200
not
mm,
asked in the
and
exam. But
1400
yes,
mm.
whatever is related. So
The
this
carrying
video is
side
just to
conveyor
show you
belt is
that how
supported
it
by
is
a
being
trough
used in the
idler that is
industries.
composed of 3 rollers. The angle of the trough can reach 45 degrees, and the return idlers are supported by flat rollers. Number 5.
Is the roller
Roller
belt
bed belt
belt
conveyor.
conveyor.
A roller bed belt conveyor is a kind of conveyor that uses several rollers which are set up on the fixed support according to a certain distance to transport goods. The roller bed belt conveyor is suitable for all kinds of boxes, bags, pallets, and other pieces of cargo transportation, mostly used for station or airport luggage sorting. Number 6. Portable belt conveyor. Universal wheels are installed at the bottom of the portable belt conveyor, which can move freely according to the stacking position of the materials, and are mostly used in the environment with a small conveying inclination angle. Retractable belt conveyor. The frame of the retractable belt conveyor is equipped with a storage belt device, which can move freely according to the stacking position of the materials, and are mostly used in the environment with a small conveying inclination angle. Number 7. Retractable belt conveyor. The frame of the retractable belt conveyor is equipped with a storage belt device, which can make the belt stretch freely in the length direction and adjust the conveyor length according to the change of the belt working position at any time. Number 8. Curved belt conveyor. The curved belt conveyor realizes the natural curves of the conveyor by changing the arrangement angle of the idler group, reducing the transfer station numbers, and solving a series of problems brought by the transfer station. Number 9.
So this is the
Steel belt
steel
conveyor.
conveyor. So this
Steel
is
belt
having more
conveyor uses
capacity. This is
stainless
a
steel
kind
belt
of
instead
apron
of a
conveyor.
belt. For the belt conveyor will release
So like
harmful
metal
substances
seats
when
are being
conveying
used,
materials with high
but here it
temperature,
is ring
while the
like
steel belt
thin.
will not. The steel belt conveyor is more suitable for material
So these
conveyed in
are
the food
modern
industry.
conveyor belts that are
Number 10.
being used now.
Special belt conveyor. A special belt conveyor is designed separately for the transportation of goods under special circumstances, which has a small range of applicability.
So
Some of these are magnetic belt conveyor, narrow belt conveyor, acid and alkali resistant belt conveyor, flame retardant belt conveyor, etc.
okay, so that's all for this one. And the question that we have already seen, this Q is depending on how it increases with the angle of repose, because tan theta is there. So if tan theta is increasing, so Q will increase. So increases is the correct answer for the given problem. So now the question is, which conveyor cannot be used to transport the material vertically? So which conveyor cannot be used to transport the material vertically? The options are belt conveyor, bucket conveyor. So let me put it here. So these notes will also be there on the same link. Suppose this is the link now. From here you will be directed to this one, and here this particular link will give you notes of the question answer classes. So whatever content we are discussing, this particular thing in the form of PDF you will be getting. So this, which conveyor cannot be used to transport the material vertically? Options are belt conveyor, bucket conveyor, screw conveyor, and none of the above. So you just think about this. Which one is the correct answer? So maybe this is hanged up. Oh, okay, yes. You just see this one. Uh, maybe yes, yes, yes. So bucket is the correct answer. So or belt is the correct answer, which cannot be used. So bucket is sometimes used, na, for correcting the vertically. Bucket is used in the vertical one. Which conveyor cannot be used? The question was, which conveyor cannot be used to transport the material vertically? So belt conveyor is the correct answer. Bucket screw could have been used if it is in the vertical position. So you just correct it, and you go to the content where it has been told. I think the lecture 2. Let me just take the slides here. Yes, so here you see in the section of the bucket conveyor, this is apron conveyor. Various discussions about the apron conveyor, you see, and this is the apron conveyor looks like. You see this metallic hatches has been made, and it is having much capacity to better capacity than the other one. These are the bucket conveyors you should see. So bucket conveyor eventually used when there is not space much for the horizontal. So bucket conveyors consist of the bucket mounted on this, and this is employed if horizontally you are not having much space, then what vertical transport could be done through the bucket. So the question had cannot. So various type of bucket conveyors are these, and in that we have already discussed centrifugal discharge elevator. So these applications you should remember where it is being used. So this could be asked, and then the continuous discharge one. Let me see. Yes. So, okay. And the last one was the positive discharge one. You see these one. So different bucket is low in the range of 35 to 40 meter per minute in that way. So that's it for this question. And the now we are going to solve another problem, that is, yes, let me just take that on the screen. The question is, uh, which could be transported through the screw conveyor. The options are coal, sawdust, salt, and none of the above. So let me just take it. Yes, it is there. So which is transported through screw conveyor? So which could be transported through screw conveyor? And if you remember the discussion of the screw conveyor, there you had this screw conveyor, you had this explanation regarding the same, like coal, sawdust, salt, what could be used. And like I told, the numerical problems you have to see. So suppose in all lectures you have been told about various numericals. See, this is the small numerical is here. And this numerical is involving this particular formula. So sometimes if formula is very difficult, it will not be given. And if it is very small, it will be given. And here you see the minimum uh, uh, velocity has been calculated, and through that the the judgment had been made about the same. So this type of question could be asked, small questions. So which is transported through the screw conveyor? You just think about this. And screw conveyor, as you remember, there will be screw kind of thing. And uh, if you remember, all coal, sawdust, and salt, all could be used. So all of the above is the correct answer for the given problem. And this throughput capacity of the screw conveyor is minimum when? The options are, so you see these are small conceptual problem and easily addressable, and at the same time if it is direct from the lecture. So throughput capacity of a conveyor is minimum when light material is transported horizontally, light material is transported at any inclination, heavy material is transported horizontally, heavy material is transported at any inclination. At an inclination. So which one is what is correct for screw conveyor? So in the screw conveyor section and through the throughput capacity of the conveyor is minimum when. So if you remember, there you have been told that the heavy material is transported at an inclination. So this is the correct answer. If I have to tell you it through the lecture slide. So if you remember this, where is this screw conveyor? Then this will be easy for me to tell you. Just wait. It has been taught before the pneumatic. So pneumatic and hydraulic was the last. So this kind of question can also be asked. You see, the calculation of the Ruby. So small calculations which are part of the big numerical could also be asked given the formula and everything. If the formula is very difficult, for example this, so this will be not asked. If asked, then the formulas will be given, and you you will be good to go with the problem. So there will be no much problem if it comes to complete it within the given span of time of the examination. So I am moving towards the screw conveyor, and these are the bucket conveyor, and lots of different parts of the bucket conveyor, types of the bucket conveyor we have discussed. So apron conveyor is here. Before this, the belt conveyor. So again, this belt conveyor is is having its uh, capacity formula to be this one. How it depends on various factors, velocity and all, that are the one thing that has to be considered. And now this, if you remember, this is the screw conveyor capacity, and here the screw conveyor capacity, you see it depends on C beta, diameter of the conveying loop, speed at which it is going, rho s solid, so density, T is the pitch between the two conveying ridges, and CFS is the factor which depends on the inclination angle and the fluid property. So there could be different parts, but yes, you see the minimum and minimum is the RPM, and that depends indirectly to D. So here heavy abrasive material, for this you see heavy abrasive material, you are having KSV to be highest and C is to be lowest, and based on that this particular value will be calculated. So KSB GQ. Q is what? Q is the capacity, and that you have already explained. You got to know this is the capacity thing, and this actually depends on the belt beta. Uh, C beta is the correction factor. It is for the inclination. That depends on the angle of the inclination beta. So if the angle of the inclination is increasing, you are having C beta to be decreasing. So if you are having more angle, then less conveying will be happening based on the value of the C beta, because Q is directly equal to C beta. So, so if you think in these terms, you will be getting that uh, heavy materials will be having better. Where was the question? This one, yes. Heavy material is composed at any and inclination is the correct answer. So now we will be moving towards the next problem, and the question is let me see which question is this. Yes. So we have already solved many of the questions, and now the numericals we will be solving. The question, this question is uh, so see some message in bucket is there. Yes. So my screen is visible. Can you confirm, Tejasvi? Am I audible and the screen is visible? Let me just wait. Why it is lagging? Yeah. The next question is the first numerical problem that we will be going to solve. And the question is uh, on pulverized coal. So coal is being pulverized, and based on that, you are having this flu, screw conveying thing. So you see, the pulverized coal is transported at 10-degree inclination, so angle is 10 degree, through the screw conveyor, uh, and the diameter of the conveyor is 0.6 meter, which runs at the maximum RPM. So maximum RPM is is the one that has to be considered. Density of the solid is given, and density of the solid is given, and you are given with the density of the solid is 1300 kg per meter cube, and the density of the solid is 1300 kg per meter cube, and ratio of lead of the screw and its diameter is 0.7. So you are given with the ratio. Compute the throughput capacity of the conveyor. Okay. So so at least in the case of this, you remember the given data is, let me just take some other pen. Yes, given data is diameter is given 0.6 meters. You are given with the angle of the inclination of the screw conveyor. So this is the screw conveyor. This is the screw conveyor you are having. Some axis is there, and the angle is 10 degree. Solid that has to be conveyed, its density is 1300 kg per meter square meter cube, and the one information that you are given with is the ratio of the lead of the screw and its diameter is 0.7. So means T to D, this is the distance between this is the pitch, this is T, distance between two screws. So this is what, 0.7. Now you have been told that uh, it is running at the maximum thing, RPM. So n max is what, is C dash by under root of D. So this we have already discussed, I think. The 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 for this conveyor, the maximum, let me just tell you about this. Yes, here you see now. Yes, you started with the screw conveyor, and here you see these are the screw. This is screw conveyor starting, and here you had these two screws. Between this, whatever is the distance, is the pitch, and you see this is the modern screw conveyor. This is hemispherical capping. This outer casing could be, say, completely circular in order to prevent the external contamination. And you see this is the capacity formula for the Q. So in this, Q equals to C beta, this area time pitch times speed at which the RPM is happening, rho s, times C G. So here C beta will be calculated based on the angle, and it can be seen that the correction factor C beta decreases with the increase in the value of the beta. The throughput capacity decreases with the increase in the angle of the inclination of the conveyor. Okay, so here if you see the calculation of the N max, so here the speed of rotation of the screw employed depends on the type of the conveying material and the screw diameter is the maximum permissible N max is. So this is N max is this C dash under root of D. And CFS depends on the filling coefficients. It depends on the value and the type of the material that is being conveyed. And some other factors are being calculated. And this KTS will be used in order to calculate the power. And Q is already you are calculating. H and L are the horizontal and the vertical height that you are going to get. And G is the gravity. So, so based on that, if you see this N max is C dash by under root of D, and the formula for the Q is C beta pi by 4 D square T n by 60 rho s C F S. Okay, so this is the one that is there. So these data will be given in the exam. So this is the assignment. So here I will be taking the data for, and from the table itself. But if it is asked in the exams, these data will be given to you just to make sure you actually understand what is happening. So this two data, one is for this. So I will be taking the formula as well, so that it actually becomes more clear to you. So this is the table for C beta, and the next table will be used for CFS and C dash. That will be in the expression for the maximum speed. So this is here. So these will be used. When you use them to get insight of the problem, then this is like from the data, from the data, these data, and again you are actually having what? Pulverized coal is transported at 10 degrees Celsius. So pulverized coal is where? The second thing. So correspondingly, you are having C dash value this and CFS value 0.32. So accordingly, the CFS value will be 0.32, and beta is 10, and C beta is 0.8. For the 10, you see 0.8 is the value, and C dash is 50. You see, C dash is 50. So this, and this you got. And now using the equation one is this one. Our formula for the capacity. If you use this formula for the capacity, so C beta you are knowing, Q equals to C beta is 0.8 times pi by 4 d square. So what was the diameter? If you remember, the diameter was 0.6 meter. So 0.6 whole square, and T is what? So T is what? T is D times 0.7, because the ratio was given. So D times means 0.6 times 0.7. Okay, and this N, it has been operated at a maximum. So you can write this N to be N max C dash by under root of D. So this N will be C dash by under root of D. C dash is 50. 50 divided by under root of D is 0.6 multiplied by 60. This is closed. Rho S is 1300. If you remember, the value of rho S you are given with. This is 1300 kg per meter cube. And the value of CFS we have already calculated. It was 0.32 based on the table that was there. So these table will be given. Or if not, the values will be given. And if you calculate it correctly, you will be going to get the value to be 42.5175 kg per second. This will be equal to 153.06 ton per hour. So 153.06 ton per hour. So what is the option for this? 153.06. Okay, this is A is correct. So this was it for this question, which is the question number 13 we had. So yeah, sorry. So this kind of question could be asked, but the thing is, if equations are too complicated, those will be given, and definitely you will be getting things up. So now, if you see this, the next question that I am going to solve is the one that is again numerical problem, is The question number 14. This is this one. Yes. So I am writing this. Yes. Let me take this here. Yes. So this question is 0.5 meter width belt conveyor is used to transport 2 ton per hour solid material having medium flow ability at 20-degree angle inclination. Density of the solid is 3000 kg per meter cube. Compute the linear speed of the belt. So you have been asked to compute the linear speed of the belt at which it is going on. So this problem is actually similar to the one that we have solved. This is directly depending upon the formula, and a small formula is there for the belt conveyor if you remember. So the is given data is, so for the belt conveyor if you remember, the discussion had a lot of juggleries in that, and if you see, if you want me to tell you the about the belt conveyor, so let's move to the belt conveyor. These are the screw conveyor. The most important thing about the advantages and disadvantages. So about the screw, you see simple design, easy maintenance, compactness required, little headroom, convenient intermediate unloading, tightness to the conveying space, which is of the special value with dusty and hot. So you can completely pack it. Like sometimes it will be hemispherical, but sometimes you can keep it completely hemispherical. Sometimes you can keep it completely closed. So in order to handle if the the sample that you are, if the particulate matter that you are handling is having some odor or hot or dusty. So so disadvantage is that uh, just let me see if something happened. Oh, yeah, so simple design. So here load accumulation in the bearing could happen, high wear on the screw. So there will be some of size reduction of the particulates because of the wear in the screw and the trough. Substantial rubbing and the crushing of the conveyor material could happen, and high power consumption is required in the screw to rotate it. So that is for it. And if you go for the belt conveyor, yes, I'm going for the belt conveyor. And belt conveyor, these are the belt conveyor you see here. Two pulleys are there, which is getting rotated. In between, some supports will be there in order to prevent the hanging of the belt if it is far long. And this is the formula for the capacity Ka C beta B square velocity times rho s, and this will be calculated based on the table that is in hand. So let me take the main content over 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 the slides where the calculations we will be making, so that you actually relate to the problem in good sense. So let me just take the content over there. So these are not given, but these will be helpful in terms of what? In terms of having complete discussion and relating it to the content that has been taught throughout the week. And anyway, the values that you have to take, this will be from the table, from the standard text, and this will be given in the examination or in the problem if it will be asked in any way. Okay, so this is it. And this After this, we will be solving some other question. So, you see, the given data is uh, B equals to 0.5. So, 0.5 meter width. So, your B is 0.5 meter. Okay. And the QM is already given, and this is 2 tons per hour. Okay, so 2 tons per hour is given. The solid material is medium. If you convert it, you will be getting 0.555 kg per hour. How it will be calculated? 2 into kg per second. This is kg per second. I have to write it. Okay, so this is the QM value. And now, if you see, the flow ability is minimum, medium. Flow ability is what? Is medium. So if you change the color of the pen and now see you see flow ability is medium. So in that sense, the beta value will be what? You see here already given 20 degrees Celsius. So for medium flow ability and the beta value 20 degrees Celsius, 20-degree angle, sorry, the rho s is 3000 kg per meter cube. You will be having C beta value. C beta value you are getting to be 0.9. Okay, C 0.9 medium one here, and you will be getting Ka value. Ka value for the medium ability angle 20, 0.1306. So if you substitute this into the formula for the Q that you had at the top is this one, Ka C beta P squared V rho S, and if you use it 0.1306 multiplied by 0.9 multiplied by B square, B was 0.3, 0.5 times V. V is asked to calculate, you have been asked to calculate velocity, times rho S, which is 3000, and this is equals to 0.555. Okay, so this is 0.55. When you calculate this, you will be getting V equals to 0.0063 meter per second. Okay, so this is the right answer for the question. So 0.0063 meter per second is the last option that is correct. Yes, so that's all for this question. And now, if you see the next problem that we are going to solve, this will again take around 10 minutes, and this is based on the uh, pneumatic transportation. So the last lecture you had. So this third problem is anyway on the hydraulic and the pneumatic transport topic. And you see this, let me just increase the size. Yes. So you see this coal, and it is having a specific gravity to be 1.3, is to be transported pneumatically with the 2 meter per second velocity, and its viscosity is equivalent to the water. Through the water, it is going anywhere. What should be the largest particle size of the coal that can be transported? So in the pneumatic transport, as you remember, the largest particle ds, whatever d was there, it was the size of the largest particle. So so if you want me to have discussion of the same, here we take it. Yes, yes, it is here. And the last one where we had we were discussing about the same. Let me just tell you about the, yes, here you see the pneumatic transportation. This was about hydraulic, and the pneumatic I am talking about. Here you see this is the dp, and this dp is depending on the, on what? This dp is depending on what? This dp is depending on the largest size. You see dp is the diameter of the largest size, largest particle to be conveyed, and that's what is the main point here. And in this conveying, the total pressure drop in the pneumatic transfer is calculated based on the pressure drop for the acceleration of the gas and for the acceleration of the solid particles. So here this will be clear to you once we will be having the complete thorough discussion on this. If you see this one, uh, then you will be having clear understanding. So here you see what are the given data. That will be the starting point for solving the problem. The starting point is like what are given. So given is density of the solid is 1300 kg per meter cube. So this is clear over here. Pneumatically transport is happening. So transportation is happening pneumatically. So this is the important line. What is pneumatic? And then the velocity at which this is happening. So pneumatically it is happening. So V minimum is given, which is 2 meter per second, and viscosity is also given. So viscosity of the liquid you are given with 0.001 kg per meter. You are asked largest size diameter. So if you remember this, this is V min, this is equals to 132.365 rho s divided by rho s plus 100 dp to the power 0.4. And if you actually put all the values, you are given with m minimum 2 equals to 132.365, rho s is 13, hmm, dp to the power 0.4. So just calculate it. dp equals to into okay 1 divided by 0.4, and this comes out to be 0.117 m. So this is the size of the particle. So here 0.117 mm is the correct answer. So let me just close this defender. This is the correct answer for the problem. So question number 15 is done. And we have had some other questions also. So that's all for this question. And if you see, let's this is the next question that I want you to solve is this one. This question says, let's increase the size to 20. Yes. This question is what are the factors on which transportation of solid on which yes the transportation of solid depends. The option A is material characteristic, option B is capacity requirement, option C is vertical transport, horizontal transport, and the inclined transport. Which is the correct answer? So all the three options are correct. One, all are correct. So that is it for the given problem. And if you remember, what are the different steps involved in the flotation process? So if you remember the flotation process steps, so what are the different steps involved with the flotation process? So this this question will be the one directly taken from the slide. So in flotation process, what you do, you take the mineral, and first the grinding of the mineral is being done. So grinding to liberate the mineral is first step. Second, that mineral has to be treated with what? With for example, like promoters or concentrators, collectors. So they will be anyway helping in terms of creating, in terms of the surface property of the particulate, like uh, hydrophobic or hydrophilic. So the reagent conditioning should be happening to achieve hydrophobic surface charge uh, on the desired particle, and then the formation of the stable froth on the surface of the flotation cell is happening. Then the separation of the mineral laden froth from the bath should happen. So let me just take the answer to this is this one. These are some different steps that are being followed for flotation process. And the next question is, like, once this flotation process is happening through the flow diagram, how you will be actually going to connect your understanding. Just increase the size of this. Yes, yes. So in the flotation process, for the recovery of the galena, spheroids and pyrite. So galena is ferrite and pyrite. This example has been taken in the class. Draw the flow diagram of the entire process and explain the role of each components for recovering galena. So in that basically four components are being added. which is NaCN, ZnSO4, pine oil, and the lime, and each had its own importance in terms of what? In terms of uh, uh, separation is. So what actually happens is if you see the general design of the of the flotation instrument, let me just tell you this one here. For example, this is the general design. You just have to see how it is related. So this is the general design of this. So there will be conditioning. So once you add the size reduction of the particulate mineral, then it is going to the conditioning. You are adding various reagents at the conditioning section, so that the surface charge and the modification at the surface is being done, so that it will be easy to float. So the flotation process is broadly divided into rougher, cleaner, the scavenger cells like this one. These are the part of the flotation cells. So the concentrate from the rougher stage are further concentrated in the cleaner stage. Okay. Uh, and then the tailing from the rougher or the cleaner stage are fed to the scavenger stage. So this is this part. And once this is done, so this two for the galena, you have been explained it in this particular chart. I will be just taking those chart exactly here in order to just explain the role of various reagents that has been added. Yes, yes. So the role of what? NaCN, ZnSO4, pine oil, and lime. What are the rule? So NaCN is here kept here. Xanthate, ZnSO4 is also there, and lime is also added. So what the role they are playing here is the question that is the part of this discussion. So if you actually think about this, you just look at the problem. The chart I have already given. So you have to just think about this. So from the recovery thing. So you have to recover the galena, spherite, and pyrite. So let me just keep it side by side. This will be more easy to explain. Just think about their roles. Okay, so and the thing that I wanted to explain you is the role of collector and the promoter. So here the NaCN is there. You see this NaSCNOR. Suppose this is there, xanthate is there. So what is the role of that xanthate and how this xanthate is playing its role? So there are four things basically. So I will be discussing all the four in detail. And so there are four things, and we will be having discussion on all them through that particular question, and then we are concluding the today's session. So here you see here xanthate is there, NaCl there, ZnSO4 is there, pine oil is there, and lime is there. So about all the questions have been asked. These are not options. You have to just explain the role of each. So the the first is floating agents. So the main thing is like flotation agents. So what are the flotation agents? If you want me to tell you, there are around four flotation agents. There could be more. Anyway, that should be helping in recovery of the particulate. Is the first one is the collectors and promoters. So these are the one, and the another one is collector and promoters you had. So these collector and promoters, if you see, after that you are having frothers. Okay, so these frothers are the another one. Then you are having modifiers. Okay, so the modifier is in the last one, and then the dispersing agents. Dispersing agents. Okay, so this entire discussion will be now concentrated to the these agents, and once you will be thorough with this, you will be easy to pick what the role they are playing up and why they have been taken in the process. So these are, I will be taking them up there. Some other sources you can also keep, but it will be more easy if I choose the the exact source from where the questions we have to take up. So let me just the class content is the first content. Afterwards we can change the scenario to some other content, other likely contents. Anyway, so this particular con is all about the promoters and collector. A sharp distinction between the collector and the promoter is difficult because promoters mainly we use generally from a monolayer on the surface of the particle. So suppose this is the surface of the particle that has to be separated. So if you are having promoters, there will be formation of monolayer. Very thin monolayer will be forming around the particle, and if it is a collector, there will be several films will be coming up. So there will be several molecule thick film will be forming in the collector kind of arrangement. They are anyway there to help in suspending the particulate. Only the one thing. And another one is that we have talked is the frothers. So what are they? We will be discussing. And then the last one is the last second one is the modifiers. Last second one is the modifiers. second one is the modifiers, and the last one is the depresent dispersing agent. Okay, so let's begin. Okay, so this is it. So if you see here, the mechanism of the sodium xanthate is what? Here the R is the water repellent group, and other SCN and the Na is the ONA is the water loving group. They are water loving group. When the compound gets adsorbed on the solid surface, the R group remains at the outer edge in contact with the water. Thus, the entire solid tends to hydrophobic and the floatability gets enhanced. So you see, like this R group will be there. The SCN group will be inside, and you see blue one is the SCN group, red one is the R group. Frothers will be at the outside, and then this air bubble will be coming up because it will be adhering to the hydrophobic part, and the particle is at the center. So So that is the rule of this xanthate. So thus the entire tend to hydrophobic. To make it hydrophobic, xanthates are being used. So in the petroleum is an example is a true collector. Other collectors are pine oil. So pine oil is being used as a collector. Cresilic, uh, cresilic oil acid. The most commonly used promoter are xanthates and aerofloats and thio carbon carbonylites. Okay, so that is the one thing, and this is something about this. Like for the benefication of sulfide ores, xanthates are most popularly uh, popular. However, xanthates are dissociated by the strong acid, and therefore they are not usually used when the pH of the medium is less than the 7. The exception is the flotation of the pyrites, which is done in slightly acidic medium. So this could be the one question that could be asked in the exam, like if it is exception for the pyrite one. So, so how much quantity of the collectors or promoters are being used generally? 0, 0.1 to 0.1 kg per ton of the solid treated. Okay, and the frothers are one. What are the frothers? Once the solid surface has been rendered water repellent by the collector or the promoter, the stability of the bubble attachment to the particle will depend on the efficiency of the frother used. Frothers are used to prevent collisions of the air bubble when they reach the surface of the water, and thereby help to maintain a persistent froth. They get adsorbed on the air water interface and thus reduces the surface tension of water. Higher alcohol, exile octyl alcohols are good frothers. Phenol and the influenza of oil are widely used as a good frother agent. So this is through the good frother producer and services. So pine oil is the frother which is being used. So you see here pine oil is being used here as a frother. Before you had promoter or collector. So here also pine oil is being used as a frother, pine oil is being used as a frother, and CuSO4 is used as a moderator. So, so that is the one that has to be taken into account. So if the copper sulfate activates the surface of the spheroid due to the formation of the copper sulfide on its surface, if copper sulfate is used in excess, it activates pyrites. So in the case of the pyrite, you see the excess copper sulfate is being used. If pyrite is used, but here also copper sulfate is used, but it is not in excess. Okay, so that is it for this question. So now, if you see the the discussion we had already about the same. So this is what NaCN. These were what? These were the collector or promoter. Okay, and pine oil was what? Frother. Lime was what? And you had CuSO4 or ZrSO4. So those are anyway used as a modifier. So that is the main thing. So you actually look at the lecture and revisit those where this has been discussed in detail, and this will be of great help. Okay, so so that is the one. So here, if you see uh, what actually happens is like where xanthate, sodium cyanide, and zinc sulfate enters. Uh, Sodium cyanide and zinc sulfate is entering here. You see here, if you see this one, so the zinc sulfate, sodium cyanide, and the xanthate is entering. Xanthate is it works as a collector. It means it prepares the surface high grow scopic for big down being that sodium cyanide and the zinc sulfates has to be modified the surface of the component. For example, sodium cyanide is used to depress pyrite. Okay, so here sodium cyanide is used to depress pyrite that we have discussed, and zinc sulfate is used to depress sapphirides. So, so for depressant for sphalerite. Okay, and this sodium that I used to depress pyrite. Depress pyrites. So this could also be the one. And whole xanthate. If complete xanthate is there, then this one is correct for this. This one is correct for this, and this one is correct for xanthate. Rule of xanthate. Role of xanthate. Okay, if option E is there, suppose. So role of xanthate is collector or promoter, and represent is the NaCN, and represent for the spheroid you had. Okay, so that's all. Now that there is what is the work of xanthate, you know, and pyrite will be depressed and galena will would be floating in the first case. So galena has been collected here. Okay, in the scavenger. So after the conditioning, next you are going to the next rougher where pine oil is added, and it is as a frother. So we have already discussed that pine oil acts as a frother. Pine oil act as a frother, and it gives the stable froth so as we know that we have already that we have already had uh, this discussion about the use of the pine oil. So similarly, if you go ahead, so adding where xanthate, lime, and copper sulfate has been added in the next. Okay, so what the copper sulfate is used to activate the spherites. So copper sulfate actually activates the spherites. Okay, this activates spherite. Here, if it is an access, it activate pyrite. And then the mixer enter into the buffer where the adding the pine oil and the time of the pine oil for the lime is maintained and the pH has to be maintained. So okay, so that's all for this one. And now the this particular lecture is completed, and we have had around 20 questions, 24 questions around in this particular lecture. So thank you so much, and we will meet again. Thank you. So next class will be there, the concluding class. So we will be meeting there. Thank you.